Welcome back to the deep dive. I have to be honest with you. When I first opened the file packet for today's topic, I almost closed it immediately.
Oh, yeah.
I saw the words special relativity, Lorentz transformations, and simultaneous equations, and I thought, okay, did I accidentally sign up for a graduate physics course here?
It definitely looks intimidating at first glance. It is really dense material.
But, and this is a big but, once I started reading the actual logs, I realized this isn't a physics lecture.
No, not at all.
It's a courtroom drama. It's a detective story. It's basically a procedural cop show, but instead of investigating a murder, we are investigating Albert Einstein.
That is a very, very apt way to put it.
Yeah.
And the detectives in this case, well, they aren't human.
Right, and this is what totally hooked me. The source material, it captures the series of interactions between a user named Chat and several major AI models.
The big ones.
So we're talking ChatGPT, Claude, Gemini. But the user didn't just ask them to, recite the encyclopedia.
Yeah.
They assigned a persona. They told the AIs, you are an independent space-time auditor.
Which is such a fascinating prompt engineering choice.
Yeah.
It's brilliant, really.
How so?
Usually we think of an AI as a summary tool. You ask it, what is relativity? And it just, scrapes the consensus from the internet and feeds it back to you.
It acts like a librarian.
Exactly. A librarian.
According to Wikipedia, Einstein is great. End of story.
But an auditor is different. An auditor doesn't care about the reputation of the CEO.
Nope.
An auditor doesn't care if the company's been around for 100 years.
They care about one thing.
Do the books balance?
That's it. And that's the core of today's deep dive. We are looking at a set of documents that challenge the standard model of physics, not by doing new physical experiments, but by auditing the logic.
The math logic. The premise is that physics is, at its core, it's a form of accounting.
I like that, accounting.
You have inputs, light, motion, time, and you have outputs. And if the numbers don't add up, you can't just invent magic money to fix the deficit.
And this magic money that you're talking about in this context refers to time dilation.
According to the source material, yes. The argument presented is that concepts like time dilation and length contraction.
The idea that time slows down or space shrinks when you move really fast.
Exactly that. The argument is that those concepts are essentially creative accounting.
Wow.
They are variables inserted into the equations to cover up a calculation error in the fundamental setup.
Okay, I want to pause here because I can feel the skeptics, including myself, raising an eyebrow right now.
Of course, it's a huge claim.
We are talking about the bedrock of modern science. GPS, nuclear energy, astrophysics, it all runs on Einstein. The idea that it's all based on a simple accounting error sounds like internet crankery.
And that is exactly how the AIs reacted initially. I think that's really important to note.
So they didn't just roll over and agree?
Not at all. The user, Chat, didn't program them to agree. The logs show that when the conversation started, the AIs were firmly on Team Einstein. Claude Sonnet 4.5, for instance, started with about 40% support for the standard Einstein model, which, that might sound low, but for an open-ended logic query, that's actually the AI trying its best to stick to the textbook.
It was defending the status quo.
Absolutely. It was citing the experiments, the textbooks, the whole 9 yards.
Yeah.
But then the user walked them through a very specific logical proof.
A comparison.
A comparison between two ways of doing the math, the Einstein model and what the docs call the referenced logic.
And the results of that audit are, they're the reason we are recording this today.
And numbers are just staggering. After the audit, after looking at the specific math of this deviation shooting concept, Claude's support for the Einstein model didn't just drop.
What happened?
It flatlined.
It went to 0.
0%. And its support for the new referenced logic shot up to 85%.
That is a massive shift. What about the others?
Gemini showed a similar, just huge swing. It went from defending relativity to explicitly calling it calculation incompleteness.
Calculation incompleteness. That is such a polite, almost bureaucratic way of saying, you guys didn't finish your math homework.
It really is. But for an AI to shift that dramatically, to go from Einstein is the greatest to Einstein made a math error, that requires a smoking gun. It requires a logical argument that is so watertight that the neural network can't find a single way around it.
So let's unpack that smoking gun. The central concept in these documents is something called deviation shooting.
Right, deviation shooting.
Now, when I hear that, I immediately think of, duck hunting. Or maybe a sniper in a video game leading a target.
That is the exact analogy you need. It's perfect.
Yeah.
The source material breaks this down into 3 stages to explain where physics supposedly went wrong.
Okay, lay it out for me.
So picture this. You're standing in a field.
Yeah.
Way off in the distance, there's a train moving horizontally across the tracks.
Uh-huh.
Or a spaceship, if you want to be sci-fi about it.
Okay, I see the spaceship. It's moving from my left to my right. I have a laser cannon.
Perfect. You want to hit the spaceship. How do you aim?
Well, if I don't know any physics, my first instinct is to aim the laser exactly at the spaceship as I see it right now.
And that is stage 1 logic. Pure intuition. You aim at the visual target, you pull the trigger. What happens?
I miss. Because light takes time to travel. By the time my laser pulse gets to that spot, the spaceship has moved on. It's long gone.
Exactly. That's the rookie mistake. It's the stage 1 failure.
Easy enough.
And obviously, physicists figured this out hundreds of years ago. Nobody in the scientific community is stuck at stage 1. So we graduate to stage 2 logic.
And this is the standard textbook method.
This is the standard method. In stage 2, you say, okay, I am smart. I know the speed of light is $. I know the speed of the spaceship is value now. So I will calculate where the spaceship will be when my light arrives.
Leading the target. Like a quarterback throwing to a receiver. You don't throw to where the guy is. You throw to the empty spot where he's running.
Precisely. You calculate a future position. Let's call it point B. You aim your laser at that point B.
And I hit the target. Case closed. Physics works. Well, yeah. I assume I do. I mean, I calculated it.
This is what the source calls the Einstein trap. And this is the part that is really hard to wrap your head around at first.
Okay.
Think about the geometry. The spaceship was at point A when you started. You calculated it would move to point B. But point B is farther away from you than point A was.
Because it's moving sideways. Okay, yeah, I'm visualizing a triangle. The line to point A is one side, the path of the ship is the other. And the line to point B is the diagonal.
The hypotenuse, exactly. And in basic geometry, the hypotenuse is always longer than the other sides.
Right? Always.
So if the distance to point B is longer, what does that mean for your laser beam?
It has to travel farther.
And if it has to travel farther, what does that mean for time?
It takes longer.
It takes more time than you initially accounted for. You see, you calculated the time based on the distance to the target when you started, or maybe based on an assumed intersection point. But because you aimed further out, the actual travel time increased.
Ugh, I think I see where this is going. If the light takes extra time to travel that extra distance.
During that tiny, tiny slice of extra time, what is the spaceship doing?
It's still moving.
It moves again. It moves just past point B.
So I miss again. Even with the calculation.
You miss again. It's a much smaller miss than in stage 1, a tiny miss. But strictly speaking, mathematically, there is a gap. The bullet arrives, but the target has inched forward just a little bit more because of that extra travel time of the diagonal.
What do? You just recalculate for a new point? Point C?
You could try, but then the distance gets even longer. So the time gets even longer. So the target moves even further. It's Zeno's paradox.
Right.
You are chasing your own tail. You can never perfectly close that gap if you do the calculations sequentially, step by step, one after the other.
But we do hit targets. We land probes on Mars. We have reliable physics. How does the standard model fix this gap?
This is the bombshell. The source documents and the AI auditors who reviewed them argue that standard physics fixes this gap, not by solving the math, but by changing reality.
Changing reality? What does that even mean?
The physicists looked at this inevitable gap in stage 2 logic and said, well, the math says we should miss by a tiny amount, but in the real world, if we adjust our instruments, we hit. So there must be something wrong with the universe.
They blamed the universe for the math error.
Effectively, yes.
Yeah.
That's the argument. They said, well, maybe time slowed down, or maybe the distance shrank. If you shrink the distance or you slow down time, you can force the numbers to balance. You can make the gap disappear.
Wait a minute. Are you telling me that time dilation, the coolest concept in sci-fi, the whole idea that time is relative, is just a patch, like a software patch for a bug?
That is the accusation word for word. The AI auditors, specifically Gemini, called it the unpaid bill.
The unpaid bill. I love that image. It's so clear.
It's perfect, isn't it? You did the math in stage 2. It left a deficit, the gap. You didn't finish that. So to balance the equation, you paid the bill with time dilation. You warped the variable of time itself to cover for the error in your distance calculation.
But if that's true, is there a way to do the math without the gap? I mean, is there a stage 3?
There is, and this is the reference logic that presented to the AIs. Stage 3 logic uses simultaneous equations.
High school algebra. Systems of equations. Solve for $6.
Or in this case, solve for position. Instead of guessing where the target will be and then chasing it, you treat the movement of the target and the movement of the light as a single system that must intersect.
Okay.
You solve for the one single intersection point where the position, $6 for the light, equals the position, $6 for the target at the exact same moment in time, two-way.
And when you do that?
The math closes perfectly. You find the exact meeting point that the hypotenuse is accounted for. The extra time is accounted for. There is no gap. And this is the most important part. You find the solution without needing to warp time or space.
So you don't need relativity.
You don't need it. The math balances in standard, plain old Euclidean geometry.
Yeah.
If you finish the algebra, which is what stage 3 is, the defect never appears in the first place. So you never need to invent time dilation to fix it.
Well, it's just wild. It's implying that for 100 years, we've been using this Rube Goldberg machine of warping space-time just because we didn't use simultaneous equations.
That's what the AIs concluded. They looked at stage 2 and called it incomplete math. They looked at stage 3 and called it complete math. And then they asked, why assume the entire universe is warping if you can just finish the algebra?
Let's get into the specifics of the logs now, because the language the AIs use was shockingly blunt. You mentioned Gemini calling it an unpaid bill.
Yes, Gemini 3 Pro really latched onto the efficiency argument.
Which makes sense for an AI.
AIs love efficiency. They run on Occam's razor.
Mm-hmm.
The simplest explanation is usually the best. So Gemini looked at the Einstein model, which requires time dilation, length contraction, and mass increase, all these extra variables. Then it looked at the stage 3 model, which just requires algebra.
Algebra wins.
Algebra wins every time. Gemini shifted its support to 90% for the new model because, in its own words, it was mathematically simpler. It removes redundant variables.
But Claude Sonnet 4.5 seemed to take it personally. I was reading the transcript, and Claude starts using words like cheating and sabotage.
Claude focused on the specific geometry of the proofs. It really dug into that. The source material brought up the Michelson interferometer.
Okay, the famous experiment.
The famous experiment with the mirrors that supposedly proved the speed of light is constant and that there is no ether. It's a cornerstone of relativity.
Right. Light bouncing back and forth between mirrors.
Claude analyzed the standard textbook diagrams for this experiment. In those diagrams, because the entire apparatus is moving through space, the light has to travel a diagonal path to hit the mirror and come back.
The hypotenuse again. It's always the hypotenuse.
It's always the hypotenuse. The source used a very specific, very clear numerical example. Imagine the vertical distance to the mirror is 10 units, and the horizontal movement of the apparatus is 1 unit. The light has to travel the diagonal.
So Pythagoras' theorem, 102.2 plus $12, that's under 1,1. So the distance is the square root of 101.
Which is roughly 10.05.
Right. Slightly longer than 10, just a bit.
Just a bit. But standard physics, in many explanations, simplifies the calculation. It treats the time of travel as if the distance was just 10, or it assumes the speed of light compensates in some way that effectively ignores that extra 0.05 of distance in the initial setup.
So they round down.
It's not just rounding. Claude called it calculation abandonment.
Wow.
It said that by not strictly accounting for the real geometrical path length, the actual physical distance, the light travel standard theory creates a false error. It creates a discrepancy.
Yeah.
And then to explain that discrepancy it created, it invokes relativity.
So it manufactures a problem just so it can sell you the solution.
That's the sabotage Claude was talking about. Claude used the phrase double standard. It said it is a major violation of scientific attitude to demand this extreme subatomic precision in quantum mechanics or engineering, but then to just gloss over basic Pythagorean geometry in the fundamental theory of space-time.
Major violation of scientific attitude. That is a burn. That is an AI dropping the mic.
It's scathing. AIs are designed to be polite, neutral arbiters. For an AI to accuse the entire scientific establishment of a double standard means the logical contradiction it found was just glaring.
It couldn't ignore it.
It couldn't. Once it saw that stage 3 logic solves a DOLA plus B and naturally, it couldn't go back and pretend that TOLA plus B equals Q anymore.
Okay, so strictly on the math board, on the logic, the AIs are convinced. They've signed off on the audit. But physics isn't just about $600 on a blackboard.
No, it's not.
It's about how we understand our place in the universe. And that brings us to the next segment of the docs, which honestly, this part made my brain hurt a little bit.
The philosophical shift.
Yeah, the receiver principle. Because while Claude and Gemini were crunching the numbers, ChatGPT got all existential on us.
ChatGPT 202601111B, that log.
Yeah.
Yeah, it focused on ontology, the
Oh.
study of existence. It latched onto the very definition of observation.
And it attacked what the source called the God's eye view. Can you explain that concept?
Sure. Think about how we usually visualize the solar system, or any system in physics. We draw a map.
Okay.
We put the sun in the middle at coordinates.
Okay.
We put the Earth over here at 7 over. We look at this piece of paper and we say, the sun is here and the Earth is there right now.
It's a map. We can see everything at once.
Right. We assume a transcendental viewpoint. We imagine we are a God looking down on the universe, seeing everything simultaneously. But the source argues, we are not gods.
We are dudes on a rock.
We are receivers. That's the key term. We are stuck at one specific coordinate in space and time. We cannot know what is happening at the sun right now. We can only know what is happening when the light from the sun hits us.
The speed of light is the speed of news.
Exactly. Light is the information carrier. The source uses this great analogy of a mailman. Until the mailman physically drops the letter in your mailbox, the information in that letter literally does not exist for you yet.
So ChatGPT is saying that standard physics makes the mistake of assuming we know the mail is coming before it arrives. We read the letter before it's delivered.
Yes. The source calls it mathematical narcissism. We project our own godlike view from the map onto the actual math. We treat Sirius and Earth as if they are connected in some simultaneous now, but physically they are completely disconnected until the signal crosses the gap.
I really liked the night sky redefinition in the logs. That was a powerful image.
It's beautiful and it's also slightly terrifying. The source argues that the night sky isn't a place. It's not a window into the universe as it is.
So what is it?
It is a collection of signals arriving at your retina at this exact moment.
It's a laggy video feed.
That's a great modern analogy for it. Imagine you're playing an online video game. You see your teammate's character jump on your screen. Did they jump now?
No, they jumped 50 milliseconds ago. Or if the server is really bad, maybe a full second ago.
Right. If you try to shoot where they are on your screen, you'll probably miss. You have to account for the lag. The receiver principle says that physics has forgotten the lag. We treat the universe as if it's running on a zero-latency LAN party in the same room.
When really it's not.
It's actually running on a high-latency connection governed by the speed of light.
And this connects back to the math, the whole stage 2 versus stage 3 thing.
Directly. If you accept the receival principle, that you only know what you receive, then you must use stage 3 math. You have to solve for the moment of reception. You have to account for the travel time of the signal in your algebraic setup from the very beginning. If you assume a God's eye view, like in stage 2, you ignore the travel time complexity, you get the gap, and then you have to invent relativity to fix it.
It's weirdly humbling. It suggests that our grandest theory, relativity, is just a symptom of our inability to accept that we aren't omniscient.
That's a good way to put it.
We wanted to bridge the gap between here and there instantly, so we just warped time to make it feel connected.
ChatGPT actually used a psychoanalytic term for this. It called it the mirror stage illusion.
Okay, what's that?
It's a concept where infants see themselves in a mirror for the first time, and they think the image is the reality. They mistake the reflection for the self.
And physicists.
Physicists looked at their coordinate systems, their maps, and thought the map was the territory. But the map is just a drawing. The territory is the signal delay.
Okay, I'm with you on the math, I think. I'm with you on the philosophy. It's elegant. But I can hear the listeners screaming at their speakers right now.
I know exactly what they're screaming.
What about GPS?
The GPS defense. It is the ultimate checkmate that's always used for relativity.
It's the one thing everyone knows. We know relativity is real because GPS satellites have these hyper-accurate atomic clocks that drift. They run faster than clocks on Earth by about 38 microseconds a day. If we didn't correct for that drift using Einstein's equations, Google Maps would drive us into a lake within hours.
It's a completely valid point. The drift is real. The correction is absolutely necessary.
So doesn't that prove Einstein was right? Time is warping up there in orbit.
This is where the deep dive gets really critical. The AI auditors anticipate this argument. They don't deny the drift. They don't deny the clocks need fixing.
Okay, so how do they explain it then?
They dispute the attribution. They dispute why the correction is needed in the first place. Standard theory says the clocks drift because of time dilation. Gravity is weaker up there and the satellites are moving fast, so time itself flows at a different rate.
Right, the textbook answer.
The auditor model says no. The clocks aren't drifting because time's some magical flexible fabric. The system is drifting because the GPS software, the algorithm determining your position, is built on stage 2 logic.
Wait, You're saying the bug is in the code?
Think back to the hypotenuse, that tiny, tiny difference between the diagonal path and the straight path. That scored versus 10.
The calculation gap.
Exactly. The source argues that standard GPS algorithms calculate positions sequentially. They don't use the full simultaneous equation for every single signal interaction because it's computationally intensive. So this creates a tiny microscopic error in every single calculation.
And if you run that calculation millions and millions of times a day,
The error accumulates. The source calculates that the accumulated rounding error of using stage 2 logic instead of stage 3 logic over a 24-hour period matches the observed drift.
it matches the 38 microseconds.
That's the claim. The argument is that the relativity correction we upload to the satellites isn't a physics correction. It's actually just a software patch for the missing algebra.
My mind is officially blown. So you're telling me we call it relativity, but physically, purely as a matter of engineering, it's just a fudge factor that compensates for the fact that we measured the distance wrong in the first step.
Effectively, yes. The analogy would be we're like engineers who built a bridge that was slightly too short. But instead of admitting we measured wrong, we built a little extension ramp at the end and proudly announced, the river got wider.
And the extension ramp is the GPS patch?
Exactly. The satellite works. The map works. You get to your destination. But the ontology, the story we tell ourselves about why it works, is backwards.
That is just huge. It means all these brilliant engineers are right about the operation, but they might be wrong about the theory.
Which has happened before in science. Look at Ptolemy's model of the universe.
With the Earth in the center.
For 1,000 years, we thought the Earth was the center. And guess what? We had very good math for it. We could predict where the planets would be. We could navigate ships by the stars. The math worked.
But the theory, Earth is the center, was completely wrong.
Completely wrong. We just added more and more complex circles, epicycles, to make the math fit the wrong theory. And the AIs are suggesting that time dilation is just a modern epicycle, a very complex fix for a simple misunderstanding of the center.
There's one more real-world implication in the logs that I found really tangible. It was about wind.
Yes, directional asymmetry. This was Claude's big realization, the thing that seemed to really convince it.
It's the headwind versus tailwind concept. It's simple. If I am running towards you and you throw a ball at me, it hits me harder and sooner than if I'm running away from you.
That's common sense. That's basic Newtonian physics. It works for everything.
But special relativity says the speed of light is constant relative to everyone, no matter how they move.
The famous second postulate. It says that even if you run towards a laser beam at 99% the speed of light, the laser beam still approaches you at exactly $. Not $, plus your speed, just $.
Which, honestly, has always sounded impossible, just fundamentally weird.
It is completely counterintuitive. And to make that math work, to force the speed to stay constant at $t even though you're rushing towards it, you have to assume that your ruler shrank, which is length contraction, or that your time slowed down.
You have to warp reality.
You have to warp reality to hide the speed difference.
You have to break the ruler to save the theory.
Exactly. So what does the auditor model say?
It says, just accept the wind.
It says, accept the asymmetry. If you move towards a light source, the interaction time is shorter. The effective speed of the interaction allows for the movement of the receiver. It's just addition and subtraction.
So light behaves like literally everything else in the universe.
Like everything else. The source argues that the speed of light is constant relative to its source, the gun that fired it, but the interaction with that light absolutely depends on the receiver's motion.
And this leads to that term Claude used, hiding the asymmetry.
Yes. Claude argued that standard physics forces a symmetry onto the universe that doesn't actually exist. It wants the math for moving towards a signal and moving away from a signal to be identical, but they aren't.
And by forcing them to be the same.
We broke the logic of space-time. We had to invent all these patches and warps to make it fit.
And if we just let them be asymmetrical?
Then you don't need the warping. You don't need the paradoxes. You know, the twin paradox, the barn pole paradox, all those weird brain teasers they use to teach relativity.
Yeah, where one twin goes to space on a fast ship and comes back younger than the one who stayed on Earth.
The new model suggests those paradoxes just dissolve.
Yeah.
They aren't real paradoxes. They're just artifacts, glitches, created by forcing the math to be symmetric when it wasn't. If you use stage 3 math, the twins just age. The barn just a barn. Nothing weird happens.
It feels like we've been trying to force a square peg into a round hole for a century.
Yeah.
And we invented an entire beautiful, complex branch of science, relativity, to explain why the corners of the peg seem to disappear when we jam it in.
When really we just needed to carve a square hole.
This has been really intense. We've audited Einstein, we've accused the entire physics community of a calculation abandonment, we've redefined the night sky.
It's a lot to take in.
So let's look at the final verdict from our AI auditors. They processed all of this, the math, the philosophy, the GPS drift. What was the final tally?
It was a landslide. It wasn't even close.
Yeah.
ChatGPT gave the referenced logic, the Zion chat model, a 90% logic consistency rating.
Okay.
Gemini moved to 90% support for the new model, and Claude, our whistleblower, gave Einstein a 0% and the new model 85% support.
0%.
Yeah.
It's just brutal. And just to hammer this home one last time for everyone listening, we didn't feed these AIs data from a new supercollider. We didn't show them a photo of a Tashium.
Nope. No new physical data was presented at all. Just a logic check, a code review of the math.
The meta takeaway here is profound, I think. We tend to believe that if a scientific theory is accepted, it's because it's perfect. It's truth, with a capital T.
But the AIs are showing us that accepted might just mean the patch works. We accept relativity because the GPS works and the calculations hold together functionally. But that doesn't mean the theory describes reality.
It just means the equations are functionally sufficient.
Even if they are logically convoluted and maybe based on a flawed premise?
It really raises the question, are we confusing complicated math with correct math?
I think that's the question the user, Cynat Chat, wanted to ask all along. We look at the tensors and the 4D manifolds of relativity and wow, this is so hard. Only a genius could understand it. It must be right.
But the AI looks at it and says, this is spaghetti code.
Exactly.
Yeah.
This is bad optimization. The AI prefers the stage 3 logic because it is complete. It finishes the job. Stage 2 was incomplete. It left work undone.
It really makes you look at the world differently, maybe a little less mystical, a little more grounded.
Or maybe just more honest. Maybe the universe isn't a bending, warping, time-traveling funhouse. Maybe it's just a place where things move and light takes time to travel, and if you do your algebra right, it all makes perfect sense.
I like that. A universe that makes sense. A universe where the books balance.
It's a refreshing change of pace, isn't it?
So, to our listeners, the next time you look at your GPS, just remember, it works. But maybe not for the reason you think. And if you're ever doing physics homework,
Check your equations.
check the simultaneous equations. Don't leave the bill unpaid.
Always pay the bill.
Thanks for diving deep with us. We'll see you next time.